Hey guys, I am going to go through a couple example problems for our first lesson. So I just want to show you how to access in Schoology. So first you're going to go to our class. You're going to click on Remote Learning Week 1, and I made a video already on how to access remote learning materials. So we're going to go to this folder here. We're going to go to Remote Learning Lesson 1. I'm going to link this video here too, so you guys, you'll know how to see that if you're watching it. And we're going to go Remote Lesson Learning 1. It's going to tell you the examples. My office hours are on Google Meet, so you can type in the nickname Mr. Williams Math. This link will take you there, and then you type in the nickname. And then I will be there probably most mornings this week, but definitely on Mondays and Wednesdays in these times. Okay. So lesson 1. All right. We are going to read our lesson, identify linear and exponential functions. And our goal is to determine if a function is linear or exponential by examining the rate of change over different intervals. Okay. So there's a video to show you how to do this, but if you watch this, hopefully you'll get the idea as well. So we're going to identify linear and exponential in some practice problems in IXL. So right here, we have a table, and it's asking us, is this function linear or exponential? So first thing we have to remember is that if we are dealing with a linear function, it's always going to be that equation y equals mx plus b. And if we remember m right here, m is our slope, and that's just a number. It doesn't change. So once we figure out what the slope is, it's just going to stay constant, and that means for every change in x right here, that it's going to go up by the same amount, okay? So if this is consistent, this change should stay consistent as well. So let's just see if it is. So, and remember, when we're finding our slope, it's rise over run, which is equal to the change in y over the change in x. Okay, so I'm going to look at the change in y here, and from -9 to -2, we're going up 7. And then I'm going to look at the change in x. So from -2 to -1, we go up. We get closer to 0. We go up 1. Okay, so if I'm going to write this slope, it's 7 over 1, which is equal to 7. Okay, so I'm just going to check now. Hey, is the rest of this function, the rest of the table, is this consistent with that slope? So from -2 to 5, that's also plus 7. And then I can see from -1 to 0, that goes up 1. From 5 to 12, that's plus 7. Same here. We have plus 1. From 12 to 19, we go up 7. And then from 1 to 2, we're up 1. So it looks like that slope stays the same. So right here, I'm going to say that's a linear function and click submit. And it's going to tell me I got it. Okay. So right now, I'm going to just clear the screen, and we're going to take a look at this next one together. So this is asking the same thing. Is it linear or exponential? So again, I'm going to look for that consistent slope. Okay, so change in y, it looks like it goes up 2, so plus 2. And over here, from -1 to 0, it's going up 1. So I can see we have a slope of 2 over 1, which is just 2. If this is linear, it would be a slope of 2 for the entire table. Okay, it's not changing because remember, it's going to look like this, a straight line. So it's going to go up the same amount over, same amount each time, and it's going to stay consistent. So right here, I'm going to check my second values. So from -4 to -8, oh my gosh, I see that I made a mistake already. I should have put right here a negative sign. So this is a negative slope. It's going down. So I made a mistake there. That would be going down, decreasing. Okay. So I'm going to look at this next one, -4 to -8. That's actually going down 4. And over here, I can see this. The change in x was just 1. So that would be a slope of -4. So I can see it's not consistent, and that would be a exponential decrease.